So good evening, everyone. Thank you for still being here. I guess you're just waiting for the beer to come, right? So we're going to talk about building your in-memory data lake, applying data quality, and finally be ready for machine learning. So just a little bit about me. So far, I've counted 4 French speakers here, so maybe you've got different figures. I'm happy to share my sources. I actually live in Chapel Hill, North Carolina right now, and I work for a company called Zaloni. We do data lake software, and I'm particularly in charge of a product called Mica, who's a data wrangling solution. And we are building that on top of Spark. So as the tradition goes, I'd like to know a little bit more about you as well, okay? Not that I'm going to completely change my talk based on what you're saying, but I need to know a little bit more about you. So who is familiar with data quality? Okay, good. So that raises a bar. Who has already implemented data quality in Spark? Okay, good. Who is expecting to be an ML guru after this session? Sorry, that's not going to happen. Okay. And finally, who is expecting to provide better insight faster after this session? Come on, be motivated. Okay, thank you. So I came to this, maybe you've seen it, it's been popular. I've come to this nice little illustration from our friends at XKCD a few weeks ago. And I think it's all over again and again, okay? Like, we started by complaining about garbage in, garbage out. And the thing is, right now, what's the thing is, with all this iterative process, this highly iterative process we're doing based on machine learning, I mean, if you get something garbage in, you get garbage out even more, okay? So this is where we should be more sensitive about data quality. So I took this very basic example to illustrate what I was saying. So I took an example based on the dinner revenue you're making by the number of guests, okay? So it's a very linear expression, and you can imagine that it should be a pretty straight line, and a really basic example for linear regression. However, what you see is that you've got anomalies in your data, okay? Because you're using a graphical representation, you can see it very easily. It's not as easy when you're having a lot of CSV files. So basically, if I remove these anomalies from my data, I can actually just get what I kind of expect, which is a very nice line next to my points, okay? So basically, I think that everything is coming to the quality of your data you're getting, okay? So, and data is coming from more and more places, okay? So we've got data from databases, okay, relational databases, which are, I guess, the core of your enterprises. You've got more and more projects running on NoSQL databases like MongoDB, Cloudant, and so on. And you've got files, okay? Files have always been there. Like Excel files are kind of polluting us in our organization, but CSV, JSON, and also now more and more multimedia files like photos and videos. And the latest tendency we're seeing is actually more machines coming from data, okay? Like services, like IoT that is coming and bringing its lot of data every second, every millisecond. So basically, based on that, we need to consider data quality. And so I've kind of tried to find a way to remember all the skills you would define, all the features you would use to define about data quality. So I came up with the acronym of CACTAR, which has nothing to do with a Mongolian warlord, but stands for consistency, accuracy, completeness, timeliness, accessibility, and reliability. So just a quick word on each of them. Consistency. You want to have to have it across the board, okay? You want every source of data to be consistent. You don't want one sensor which is sitting next to another sensor to report different type of humidity, for example, okay? That's consistency. Accuracy. As I said before, I was born in France in October, so I'm actually on the 5th day of October. But here, if I write it the same way, my date's the same way, it's actually, I'm becoming like I was born on May 10th, okay? So the thing is, it's a little bit confusing based on the format of the data. Completeness, okay? Missing field, values, rows, timeliness. How recent is your data? 45 million Americans are changing address every year. So if your address you have in your database is something like 3 years old, the probability it's wrong is probably very high. And accessibility, okay? And this is where it's easy to be able to easily access data and be able to visualize it. So based on that, when you've got your cactar, you can do operations, you can do decision making, planning, and of course machine learning. So another few example is this is a bad data story. Okay, so everybody is aware of Hubble, which was partially blind because of 2.2 nanometer errors. So coming from France, I know what a nanometer error is. Since I lived in the US, I've got to learn all these inches and feet and all these things, and it's a little bit confusing to me. But I understand that when you're going from one to another, you can actually lose a little bit of data. And this is at least an urban legend that says that the blindness of Hubble was due to this imperial to metric conversion. So that's kind of a funny example. A less funny example is the explosion of Challenger in 1986. Investigation have shown that it was actually due to a O-ring being defective. Okay, so this was in the booster, and this O-ring was actually supposed to, well, protect the different mix to not touch each other. And actually, what happened is it was defective, but the root cause to this defect was data was not reported correctly. The database was mentioning the O-ring, but it was not mentioning as important as it was actually in the dual Challenger thing. Same thing for the lack of data lineage. The reporting and the risk due to this was not actually clearly identified. Okay, and I've got in the slides, you'll see the links to the research that proved that. So what can we do? The first thing is we can do scripts and the different things of scripts you can do. Okay, so basically you've got your different source of data, and you want to put them into Spark to do machine learning. So you clean your sources with scripts, but the drawback of that is it's highly I/O intensive. It's require a lot of space, and it's very difficult to parallelize unless your developers are really good, and we are already. Next step is that's probably not really the right step for this kind of workload. So you could use Spark SQL. Okay, you put everything in Spark, and you've got everything in memory. But SQL is a little bit limited, so you can't do everything. So the alternative we picked was to actually use UDF. So UDF stands for user-defined functions, and you can extend SQL. You've got either you can use UDF directly into your SQL statement, or call directly a call UDF method. This allows you to benefit from Spark's cluster architecture and on the distributed processing. Okay, so much faster, much more reliable. So how do we do that? So basically, the way I like to create acronyms, I created the SPRU acronym. So I sprue my UDFs, and I create. So first I look at the service code. The service code is basically what is actually validating your business logic statement, okay? This is probably code that is already existing in your company. And because those are rules that everybody's over time been maintaining and developing. Then the second part is plumbing. Basically, you take your UDF, which is connecting your service code, your service logic to Spark. Okay, basically that's the way you enrich Spark. And then then the third step is you register. You need to tell Spark about, hey, I've got this new feature, please use it. And finally, you use it. Okay, so here comes the spoofing from. So as we are all mostly geeks, we like to see code, and this is a bit of an example. So I did not go through service code. Okay, so in the case of my linear regression before, you can I just skipped the service code. Okay, you can imagine what's the business logic between the two different anomalies, but that's how I did the plumbing at least. Okay, so the plumbing is a UDF. Okay, so if we read the code together, you can see here that I create a simple class which is implementing UDF. Okay, and it takes a double as a parameter and it returns a double as a result. Then I just implement the call method. And based on the call method, you see that it has the same signature as what I just defined before. Okay, so I give it a price. From this price, it's calling my service, and it checks the minimum price, and it's returning the minimum price. When it's not matching, when the rule is not matching, it returns -1. Otherwise, it returns just a price. Now I need to register it. So when I register my UDF, I just take the session, okay, get the UDF method, and basically call the register method. When you call the register method, you need to give it a name, which is a completely made-up name. If you want to call your method XYZ, you call your method UDF XYZ. You give it a class. Okay, to which it's actually going to apply that, so your UDF class. And the third argument is your returning data type. And if you follow it a little bit, it's a double. Okay. And then finally, you can actually use your UDF. Okay. So to use your UDF, we'll first have to prepare it, but our data. So the first block here is I'm going to read any CSV. It could be any kind of data. Okay. Here you can see that I'm calling that Spark 2, so I'm using the built-in CSV parser. It's inferring the schema. It doesn't have a header, and it just loads a file name. Then I'm just doing a little bit of cleanup here. I want my first column to be called guest, and my second column to be called price. And after that, if we can execute that, and this is the kind of result we're getting. Okay, so it's a famous data frame.show method. Okay, so number of guests, price, matching price. Okay, and you can start seeing things like it's not really okay. Like for 6 guests, sometimes I've got $50, and sometimes I got $112. Then I'm going to call my UDF. Okay, so basically I'm calling my data frame with a column. I'm creating a new column called price no min, and I'm calling the UDF price minimum rule. Okay, and as an argument to this method, I'm giving the value which is in the column price. So if I look at the result of that, well, you see that some values in price no min are actually -1, okay, as I just said before. So if you were using normal SQL, you would just drop all the rows where price no min is equal to -1. But in Spark, you've got to create another data frame based on a select, and you get just a positive value. Okay? So that's what it does. And finally, my data frame is looking as that. So based on that, on this very quick operation, based on this few line of Java, you've got your business rule implemented and your data is being cleansed. So it comes to a philosophy of store first, okay, ask questions later. You built an in-memory data lake, okay, so basically you put everything in your data lake. It's easy to do. You store the data in Spark. We've always trusted its data type detection capabilities, which are linked to the data source, but it's been really doing a great job for us. Okay, so you give it quantities of data in CSV files or in JSON files, and it just loads the data, discovers the data types, and does all the things almost by magic. You build your business rules with the business people, or you reuse them if you have them in your libraries. And then you can create your trusted data and data lake, okay? And of course, once you're ready for that, you can apply machine learning algorithm on top of this thing. So in the example I've chosen of a really basic linear regression, which is probably the first exercise that everybody's doing when he's doing machine learning. And in MLlib, you will need a column called label and a column type feature. The column type label is a double, okay? And it's good because we're using double values so far. The features are a column, a type of type vector UDT. And vector UDT, as you can see before in my data set, well, I don't have a vector UDT. So basically, I need to create some vector UDT. And what do I do to do that? Well, the same thing as before. I created a UDF to format my data and create a UDT, a vector UDT, okay? So same thing as before. Got my Spark session, register. I called my UDF here vector builder, and it's also an instance of vector builder, which is going to return this time a new vector UDT. Okay. Then I'm creating my two columns, label and features. Label being a copy of price, just a simple copy of price. And my feature is actually being built and created as a feature based on the column guest. Okay, and I'm creating this vector. Then you've got this long machine learning code where you've got to create your model, and at some point, well, you've got your model. And once more, if you're interested in the code, please feel free to just get it from GitHub. And at the end of it, I'm just calling the predict method of my model based on the new features, and I can actually ask a prediction and display the prediction. Okay. So in this case, my features is I want to know for 40 guests how much am I going to pay, and basically the result is that we are having, and you see all the columns here in my data frame. So it's the original column, filtered and cleaned, guest and price. You've got this new column, label, okay? You've got this feature column as features as a vector UDT, the prediction at the end of it, and the prediction for 40 guests is going to be about $221, okay? Very basic example, but illustrates the use of UDF in your creation of your application. So as key takeaways, I would recommend to create your data lake in memory. So basically you take your data, put them in memory, start working with them. So it's the same principle, store first, ask questions later, sample your data, okay, just to spot for anomalies you can see. It's easier when you can actually visualize them. When you've got them in a data frame, it's a little bit more difficult. You can use notebooks also for that. And you can rely on Spark SQL and UDF. So to build your consistent and coherent data set, okay, as we just did. And then you can rely on UDFs for preparing your data to the formats that MLlib is expecting, okay? And finally, use Java. Enough of this Scala nonsense. So thank you, everyone. I went a little fast, so we get to the beer quickly. And please, questions.
So for questions, there will be a mic in the middle.
So why, I didn't quite understand why you wanted your data lake to be in memory.
Well, because I don't insist of having it in memory. The thing is, compared to a lot of operations that I've seen during the ingestion process of the data into your data lake, what I've seen quite a few times is that people are just keeping it on disk. And it's super I/O intensive. And I think that if you just put it directly in Spark and benefit from Spark, that would be faster and a more elegant solution. Does that answer your question? The thing is, I've got really very bright light in my face. So
you talked about identifying and removing anomalies helps your model perform better.
Yes.
But how, if you're ingesting new data and you're trying to predict the value, how do you know if it's one of those anomalies? Because if you just use the regression, then it's going to be way off.
Well, that's where I think that sometimes we forget as IT people to use a business people, okay? So in my very basic examples, the anomalies were when you've got this 20 people or so, you've got these people paying something like less than $20 for the entire table. That's a business rule. You know that it's not, nobody can pay less than $20. The other anomaly was a cluster of points, which you could actually think it was actually linked to when you're between 5 and 6, you would have this thing. This was for my example, but this is coming from the business analysts. They tell you when they do business rules, which is the expected behavior. That's been my experience so far.
Cool. If there's no more questions, let's give a final round of applause to JG.
Thank you.